This is the solution to question 12 for HCAHPS 725, Statistical Process Improvement. The solution was provided by Dr. Maria Urio. The question asks for us to compare the performance of Medstar Washington to other DC-based hospitals. We have to exclude Medstar Georgetown from the analysis. And we have to download data from 2014 to the present time. We are extracting available files from the Hospital Compare website. In this situation, we have data from 2015 all the way to 2020. And these same data sets were extracted in question 4. Within each folder for a given year, we're going to be looking for the HCAHPS-hospital file. And we're going to be extracting from each year that specific file. And eventually we should end up, depending on the number of years you want, 5 or 6 files to work with. In this slide, we're making assumptions concerning the X-bar chart. We find that the following assumptions have been met: that the satisfaction rating is a continuous scale, that patients are independent from each other, and that data has a normal distribution. Now, in the lecture notes for this specific homework, you would see that Dr. Alemi had indicated that quadratic or uniform or exponential distributions always end up having a normal distribution. Upon opening Python, you're going to be importing the following libraries: pandas, numpy, math, and matplotlib. In addition, we're going to be working with 5 time periods, and we're looking at 2014, 2015, 16, 17, and 18. And the file type is a CSV, and you have to use pd.read_CSV to read those files. Engine equals Python is used to prevent Unicode decode error. Without using the engine equals Python, you'll not be able to read your data into Python. We need to check the column names in the data frames. We find that in the 2018 year, the column names changed. At least the critical ones that we'll be using changed. And these were different from the 2017, 2016, 15, and 14 years. This slide shows you what the column name changes were. So 2017 all the way to 2015, the column names are the same. But in 2018, what changed was the facility and facility name instead of using provider ID and hospital name. And also the measure start date and the measure end date changed to start date and end date. And again, all these are critical attributes that you need to use in your calculation going forward. Each of the original files have about 22 columns. We don't need all those columns in our analysis. So in this slide, I'm showing you how to minimize the number of columns and select only those that you need. And we're creating new data frames and naming them by the year. So we're using provider ID, hospital name, HCAHPS measure ID, HCAHPS linear mean value, measure start date, and measure end date. And for 2018, that changed to facility ID, facility name, start date, and end date. And furthermore, we're saying we only want within the measure ID column the measure that says HCOMP6 linear score. So we're narrowing our columns and narrowing our rows so that we have a compact data set. You should check all your data frames from the previous step, but on this slide, I'm just showing you the data frame from 2018 that was filtered. And now, based on our limitations and specifications in terms of the columns and the rows, what we have here is the data set that shows that the HCAHPS measure ID is only the HCOMP6 linear score. We have the mean value, the start date, end date, the facility name, facility ID. But in the mean value column, you can see that not all the values are numeric, that we have an entry in there that is clearly string. We need to determine the data type from each of the data frames. For each of the 5 years, the data frames indicate that the HCAHPS linear mean value is of object data type. This needs to be converted to a float data type. In this slide, we're checking for non-numeric data within the HCAHPS linear mean value column. We are doing that by using the data 2018 filtered and then the HCAHPS linear mean value dot as type float in quotes. And then you'll get a traceback feedback message that includes a value error, and it shows you that it could not convert the not available string to a float. So I'm not showing the whole error message. You have to scroll all the way down to the end of the error message, and you'll see the message value error could not convert string to float, not available. We're going to convert the not available entry with 0 and then convert the HCAHPS linear mean value column to a float. So it's going to be occurring in 2 steps for each data frame for each given year. We're checking how the column has been updated. And in this slide, I'm just showing data from 2014. And you can see that the not available entry have been changed to 0. And then the data type is a float. We are looking at the updated 2018 data frame by using the dot head bracket function. And we can see that the HCAHPS linear mean value now has numeric values and that the not available has been replaced by 0. So this is just another view of the data frame from the previous step. We are applying conditions to the data frame. We're doing that by using a variable called PIDS, and the variable has the hospitals we're interested in. In this case, we've excluded Medstar Georgetown Hospital from the list. And this variable is called in the code by saying essentially you want to create a new data frame where within the hospital name you are filtering the entries by the values within the PIDS variable. This slide shows the output for the conditions that you've applied. We are determining the number of rows and columns in the new data frame. We need to calculate the average satisfaction rate at Medstar Washington Hospital across all 5 time periods. We do that by creating a variable called HOSP, and inside that variable we're going to enter the words Medstar Washington Hospital Center, and then we're going to be calling that variable in the ensuing data frames by saying, in the new data frame, we want you to generate a data set that has only within the hospital name column the name of the hospital called Medstar Washington Hospital Center. You do this for the 5 years, and then after that you're able then to calculate the average satisfaction for each year by using the dot mean function for the HCAHPS linear mean value column. In this slide, we're going to be calculating the average satisfaction rate in other DC hospitals across the different years. We're going to apply the not equal to operator within the hospital name column, where we want the condition to be such that the entries are not equal to Medstar Washington Hospital Center. So what you're going to end up with is anything else but Medstar Washington Hospital in that column. In this slide, we're creating a data frame containing DC and Medstar Washington data from all 5 years in order to determine the grand average. Formulas for the grand average and standard deviation are shown on this slide. We are now creating a data frame containing DC satisfaction data from all 5 years. We need to check for normal distribution, and this slide shows you how to do so. We begin by using again the data 2014 filtered 2, and we're going to be working with the HCAHPS linear mean value for all the 5 years. And essentially what we're doing here is kind of like stacking the data on top of each other, if you can think of that. And so we're using the .append function to do that. And towards the end, you've appended all your files together. So you take the last appended file and you plot it. And in here we're using the .plot.hist function. This slide shows the average satisfaction scores for the DC hospitals across 5 years, and on the right we have the corresponding standard deviation values. We are now counting the number of hospitals in DC across the different 5 years, and then the z-stat value that we'll be using is 1.96. We're creating a data frame that will be used for holding values that can be used for the calculation of the upper and lower control limits. We're using more descriptive names for the column names, and this is how you can rename your column names. This step shows how to calculate the UCL and LCL values. The code for plotting the X-bar chart is shown on this slide. This is the chart generated showing satisfaction rating between Medstar Washington Hospital versus DC competitors.